Imagine it's 2035. You're flying silently at supersonic speeds over Chicago, and your biggest worry is not your physical health, because your doctor just, successfully grew back your damaged tissue using genes you happen to share with a salamander.
Which is just wild to even think about.
It really is. Welcome to episode 502 of AI Brief. I'm Amin, and I'm here with Leah. Today, we're looking at how artificial intelligence compute is making that exact science fiction reality happen right now.
Right. We've got a lot of ground to cover.
We really do. We're going to unpack how Alphabet is quietly maneuvering to own the entire artificial intelligence board rather than just playing a piece on it. After that, we'll explore those truly mind-bending updates happening in the physical sciences, from that supersonic travel making a comeback to breakthroughs in actual limb regrowth.
Oh, and don't forget the tool.
Exactly. Finally, we'll give you a comprehensive rundown of the latest autonomous tools designed to completely change how you work at your desk today.
And, the overarching theme tying all of this together is really acceleration. We're watching how rapid advancements in code and silicon are, well, they're no longer confined to digital spaces. They're suddenly spilling over into reshaping the physical world around us.
It's literally jumping off the screen.
It is. That raw computing power is fundamentally altering everything from the sky above us to human biology itself. It's moving so fast.
Let's start with probably the biggest narrative flip in the market right now. For a long time, the dominant story was that Alphabet was going to be a search engine casualty of this whole artificial intelligence revolution.
Yeah, the classic innovator's dilemma narrative.
Exactly. The narrative was that chatbots would kill traditional search and their core business would just collapse. But that story is completely inverted. Alphabet sits on the edge of becoming the world's biggest company, and it is arguably the market's cleanest winner in this space.
It's a massive turnaround.
Investors are finally looking at the board and realizing what this company actually owns. They own the foundational models, they own the cloud infrastructure, they design their own chips.
On the distribution.
Right, they control global distribution, and they possess the cash machine required to keep compounding all of those advantages. The data behind this shift is absolutely striking. Alphabet's market cap recently closed at approximately $4.8 trillion.
Wow.
Yeah, which puts them exceptionally close to NVIDIA, which is sitting at roughly $5.2 trillion.
Oh.
But the momentum tells a totally different story. Since October 31st, Alphabet's stock has surged 43%.
Wait, 43% in that short of a window?
Yep, and over that exact same stretch of time, NVIDIA is up only 6.3%. You can think of Alphabet's strategy as building an entirely self-sufficient digital nation that aren't just buying raw materials from suppliers anymore.
They own the whole pipeline.
Exactly. They have built the entire supply chain from the ground up, starting with their Gemini models, running through their custom TPU chips, and ending directly on the screens of billions of users.
And breaking down why that vertical integration matters is just so crucial for understanding where the technology sector is heading. When a company owns every single layer of the stack, they insulate themselves from outside pressures and, supply chain bottlenecks.
It's a massive defensive moat.
It really is. A perfect example of this strategy in action is the recent announcement regarding their tensor processing units, or TPUs. These are the custom processors Alphabet built specifically for machine learning workloads.
The ones they usually keep for themselves.
Right, but it was just announced that these TPUs will soon be available for Google Cloud customers to run in their own private data centers. That is a massive shift in distribution. Analysts are projecting that TPU-related infrastructure revenue will reach about $3 billion in 2026.
That's a solid number.
But wait, by 2027, that number is expected to skyrocket to $25 billion.
Oh, wow. That's a serious jump.
And despite these massive growth projections, the stock is trading at roughly 28 times estimated earnings. Analysts have consistently been lifting their profit forecasts because Alphabet posted stronger than expected growth in both search and cloud services, which completely reset the narrative around their exposure to new models. Gemini is now viewed by the market as one of the strongest foundational models available.
I want to pause on that vertical integration point because that is really where the magic happens. If you're NVIDIA, you sell the shovels for the gold rush. But if you're Alphabet, you make the shovels, you own the gold mine, you control the roads leading out of the mine, and you own the marketplace where the gold is sold.
It's the ultimate monopoly setup.
It is. If a competitor lowers the price of a foundational model, Alphabet does not panic because they can just monetize through search or cloud. They become an all-weather winner. They are far less vulnerable to sudden market shifts than a single line of business rival. If spending continues to broaden across the sector, Alphabet is positioned to capture value at every single stage of the process.
That insulation is their moat. It means artificial intelligence leadership is not solely about manufacturing the fastest ship anymore. It's about how efficiently you can deploy that compute power across an entire ecosystem.
So, drawing a direct line from that massive infrastructure scaling, that same massive computing power Alphabet and others are hoarding, is exactly what is accelerating developments in the physical sciences. The processing capabilities being deployed in those data centers are the exact tools researchers use to model complex physics and comb through billions of genetic sequences. Let's look at what that compute is actually doing out in the real world today.
So we have four massive breakthroughs to walk through, starting with a major development in aviation. The days of spending 14 hours crammed into an airplane seat may soon be coming to an end. NASA's X-59 aircraft recently hit 0.98 Mach during a test flight.
Okay, so just under the speed of sound.
Exactly. This marks a significant milestone in the race to bring supersonic travel back, specifically for flights over populated areas. The engineering marvel of the X-59 is its physical design. The aircraft features a remarkably needle-thin nose.
Well, I've seen pictures of this. It looks almost like a dart.
Right, and this shape is specifically engineered to reduce the traditional sonic boom. Instead of a jarring noise that shatters glass, the design turns the sound wave into a quiet thump. NASA is now preparing to fly this jet over real communities within the United States to test public reaction to this quieter acoustic signature.
Let's break down the physics of that needle nose design because it is brilliant. Think of a standard commercial jet plowing through the air at supersonic speeds, like a blunt boat hull slamming through water. It creates a massive noisy wake. All those sound waves stack up on top of each other and merge into one explosive shock wave. That is your sonic boom.
And the X-59 changes that.
Exactly. The X-59's nose acts like a razor-sharp canoe. It parts the air so gradually and smoothly that the shock waves are separated. They never have a chance to merge and create that explosive boom. If the public accepts this gentle thump instead of a boom, it paves the way for commercial supersonic flights over land, which would drastically alter global transit times.
It really shifts the paradigm of travel. Now, moving from aerospace to biology, scientists are claiming to have found what they call the Holy Grail gene for limb regrowth.
The Holy Grail. That's a big claim.
It is, but it comes from a fascinating cross-species study spanning axolotls, zebrafish, and mice. Researchers were looking to crack one of biology's most complex mysteries, and they have reportedly identified SP genes as a shared driver of physical regeneration. By utilizing gene therapy to activate these specific genes, the scientists partially restored bone regrowth in mice.
Wait, hold on. I need to clarify this. Are you saying humans already have these exact regenerative pathways hidden in our DNA? Because if we share these genes with salamanders, why do we just form scar tissue when we get injured instead of, growing the bone back?
That is the crucial detail. We do share these pathways. The biological mechanism at play here is about gene expression. When an axolotl loses a limb, its body activates these SP genes to essentially reverse engineer the missing tissue.
Okay, so it turns the genes on.
Right. In humans and mice, those genes are present, but evolution has effectively turned them off in favor of rapid scarring. Scarring is a great survival mechanism if you are trying to stop bleeding quickly in the wild, but it physically blocks regeneration.
That makes a lot of sense.
So the researchers used gene therapy to essentially flip those dormant SP genes back on in the mice. If scientists can fully unlock the rest of this genetic mechanism, the long-term medical implications are staggering. We're looking at a potential future where medicine involves growing back lost limbs or organs entirely, rather than replacing them with mechanical prosthetics.
The scale of that is unbelievable. And speaking of scale, our third development takes us to astronomy. Scientists claim they have discovered an atmosphere around a tiny, icy planet located in the Kuiper Belt, which is far beyond Pluto.
It's an incredible find. This makes it the smallest object ever found to host an atmosphere. The atmosphere itself is incredibly faint, estimated to be 5 to 10 million times thinner than Earth's.
So not exactly breathable.
No, definitely not. And while a rock in the Kuiper Belt isn't a destination for future space tourism, the scientific implications are profound. Normally, we assume objects that small and that far from the sun are just dead, frozen rocks. They shouldn't have the gravity or the heat to maintain any sort of gas layer.
Because they're just too cold and tiny.
Right. If this detection is verified, it proves that small, frigid whirls across the outer edges of our solar system are surprisingly active. It implies there is geothermal activity or complex environmental dynamics happening under the ice that we previously thought impossible for objects of that size.
It completely rewrites our understanding of the outer solar system. Finally, bringing it back to Earth and into the field of longevity, there's an incredible new study involving mice that has successfully reversed liver aging. And the mechanism they found to do this is completely unexpected.
It really is. The researchers discovered an unexpected weapon against liver aging and liver cancer using the microbiome. In the study, scientists extracted and preserved samples of gut bacteria from each mouse when the animals were young.
Okay, so they banked it.
Exactly. Then, as those exact same mice aged naturally, the researchers transplanted their own preserved youthful gut bacteria back into them. The results were extraordinary. The treated mice exhibited significantly less inflammation and reduced liver damage. Most importantly, they showed 0 cases of liver cancer.
0 cases. That is wild.
Yeah. The mechanism comes down to the gut-liver axis. Your gut bacteria actively process nutrients and filter toxins before they reach the liver. As we age, that bacteria degrades, sending more inflammatory signals and unfiltered toxins straight to the liver, which drives aging and cancer.
So the old filter is basically breaking down.
Exactly. Restoring the young microbiome essentially resets that filtration system. If this specific treatment translates to human biology, it could open up a completely new frontier in cancer prevention.
That longevity study forces a fascinating question for anyone listening. If scientists are successfully preventing liver cancer in mice by banking their young gut bacteria and utilizing it as a later life treatment, should humans start banking their gut bacteria right now? It makes you wonder if preserving a sample of your microbiome in your 20s or 30s will become a standard biological insurance policy. You just keep it in a freezer somewhere so you can reboot your immune system in your 70s.
It sounds like science fiction, but the biology supports the concept.
All right, bringing the conversation from the outer solar system and future biotech back to your desk today, we have a rundown of the trending artificial intelligence tools making waves. These are 8 applications leveraging that exact same acceleration in compute power we talked about earlier, but designed to change how you work right now.
These are moving so fast, it's hard to keep up.
It really is. First up is Wispr Flow. This is a Mac dictation application designed to write in your specific style across every application you use. It features auto edits and a dedicated command mode. Picture drafting complex emails or highly technical code documentation completely hands-free while pacing around your office. Instead of sitting there typing and retyping, you just talk naturally.
And it just handles the formatting.
Exactly. The application captures your thoughts, structures them logically, and formats them perfectly in your professional tone directly into whatever window you have open.
That pacing aspect is huge for cognitive flow. Getting away from the keyboard entirely changes how you structure an argument.
It really does. Second on the list is Kilo Code version 7 for Visual Studio Code. This tool allows developers to run parallel artificial intelligence agents directly within their coding environment using free, open-source tooling. Think about the nightmare of updating a legacy code base.
Oh, nobody wants to do that.
Right. Instead of doing it line by line, you can task 3 separate autonomous agents to refactor 3 different parts of the code simultaneously. They do the tedious rewriting while you focus purely on reviewing their final logic, acting as the senior reviewer rather than the junior typist.
That's a massive time saver.
Huge. Third is Monid 2.0. You can think of this as an open router specifically designed for agent tools, but really it operates like a master dispatch center. Right now, you probably waste time guessing whether Claude, GPT-4, or an open-source model is smartest for your specific coding or writing task.
Constantly.
Well, Monid 2.0 eliminates that guesswork. You send your workflow request to Monid, and it automatically routes it to whichever model is perfectly suited for that exact job, saving you both time and compute costs.
That makes so much sense for efficiency.
Yeah, and fourth is Mindra. This platform gives you access to full agent teams that you can actually delegate work to. This represents a massive shift in how we work. Imagine you have a massive, multi-step market research project. Instead of prompting an assistant step by step, so, asking it to search, then asking it to summarize, then asking it to format, you just step into a manager role.
So you're just giving them the final goal.
Exactly. You hand the entire objective off to Mindra's team of agents and let them coordinate the execution among themselves.
That is a transition from prompting to managing. It requires a completely different skill set.
It really does. Fifth is Flowly. This is a personal artificial intelligence assistant that operates native to your desktop environment. Think of it as a persistent ambient helper living right on your screen, completely aware of your local context. Think about those days where your downloads folder is a mess of random screenshots and untitled spreadsheets.
Oh, I know that feeling all too well.
Right. Flowly can jump in to organize your local files, rename scattered documents based on their contents, or pull specific data points from a spreadsheet to build a report without you ever having to open a web browser.
That is incredibly practical.
Definitely. Sixth is Flare. This is an AI-native, voice-first social application built primarily for Gen Z. If you are a creator or a brand trying to connect with younger audiences, Flare completely shifts the paradigm away from text-based social media. It facilitates audio-first interactions, using artificial intelligence to curate, moderate, and enhance voice conversations, creating a much more intimate social layer.
It's fascinating how voice is making such a big comeback.
It is. Seventh is PandaProbe. This is an open-source agent engineering platform, and it is absolutely critical for enterprise safety. Before a company lets an autonomous agent loose on their customer database, they need to know it will not hallucinate or delete records.
Obviously. You can't just unleash these things blindly.
Exactly. PandaProbe provides a secure environment for developers to safely build, customize, and rigorously stress test their own business agents before deploying them into a live production setting.
That's essential infrastructure.
And finally, we have Rosentic. This tool solves a very specific, brand new problem we didn't even have 6 months ago, catching when coding agents break each other. If you have a software team deploying multiple autonomous coding assistants across different branches of a project, Rosentic acts as the ultimate supervisor.
To stop them from stepping on each other's toes.
Exactly. It prevents massive headaches by constantly scanning the repository to ensure these autonomous agents do not create overlapping merge conflicts or break each other's logic before the code is finalized.
Synthesizing this entire list of tools, there is one overarching takeaway for you to consider. We are observing a definitive permanent shift from conversational applications to agentic systems. The era of simply chatting back and forth with a model to generate text is ending.
It's already feeling outdated.
It really is. The era of managing a team of digital workers has officially begun. The tools you deploy moving forward will not wait for your prompt. They will operate autonomously to execute complex workflows.
So pulling all of this together, from Alphabet's massive vertical integration to these autonomous desktop tools, consider this final thought. Trillion-dollar companies and local applications are both moving rapidly toward fully integrated autonomous systems. The infrastructure is being laid down right now. How quickly will you need to adapt your own career to become a manager of these systems rather than a manual operator of the tasks they perform?
The future economy clearly belongs to those who learn to effectively delegate to these digital workers.
Be sure to follow and share the podcast so you do not miss out on these daily shifts. See you in the next episode.